Okay, so today we're going to be dealing with problem number 45. This is coming from chapter 18, and so this is going to ask us a few different questions about the circuit and how it's going to work and in steady state and all that kind of good stuff. So we're going to start off, it first ask us, here are the questions up here. It's first going to ask us which one of the following statements are true. So we know it has to be 1, 2, and 4 because number 1, it says we know that it is true because we know that as the electric field moves from positive charge to negative charge, the electric field direction at positive terminal of the battery is away from the terminal towards the negative terminal. So we know that the electric field at location B is towards the top of the page. You can also do that by the right-hand rule. We also know that the second one's true because we know that the wire here at C and F have the same thickness, and so we know that they're going to have this same electric field. And then number 3, we know that it is false because we know that because of the thickness of the wire being smaller, it's not going to be proportional. And then number 4, we know that because of the current node rule, the current passing through the thick wire and thin wire is the same, so that we know that the electric field, the electron current at F and D are the same. And so that is going to be part A. Part B, we're going to use the loop rule, and so we know that that's going to be delta V1 plus delta V2 plus delta V3, and etc., plus EMF is equal to 0. And so we know that we do that. So we know that we have 18 volts because that's given to us. It's going to be 2. So A to C and E to G are going to be the same. So you're just going to multiply that by 2 instead of writing it twice because it's the same magnitude. And then we're also taking account here for the small cross-sectional area. So that's going to be our loop rule. So for C, we know that we're going to use, I always like to think of it as a water pipe. That's how it was explained to me in class. It's kind of stuck with me. We know that whatever's coming in has to be the same as going out, because even though you have your little pipe here, this can't be more, the pipe's going to bust. It can't be more water coming out of that, or the pipe's going to bust. And so that's how we know that IB is equal to ID is equal to IF. They're all going to be the same. And so for part D, we are asked to approximate or use the appropriate equations to find the magnitude of E of D and E of F. And so that's what we're going to do here. So we're using that loop rule again, and we're just going to plug in because we know what E is equal to. And we're going to, we don't know what E is equal to. We know what L is. And so we are going to solve for both of these E's, replace E2 in terms of E1. We get that from using that from part C. And then we just solve for E1 and get that number. And that's going to give us 0.947 is equal to E1. Just a bunch of algebra there. You can just kind of use your calculator for that one. And then for E2, we're going to continue up here. You're going to plug that back into this formula. And you're going to solve for E2 is going to be equal to 22.47. And then in part E, we are asked to find the electron current at D. So that's what this is going to be. I is equal to the electron current. And then this is the formula we find for that. It's found in the textbook. It's where I got it from. And so we know that these are all given to us, or we found them at some point in the work so far. And you just kind of plug all those in, and it's going to be equal to 2.65. And so that is going to be how we find those.